Hello everybody. Today we're going to go ahead and focus on a little bit of Unity, a little bit of Prism, a little bit of console applications, but really we're going to try to focus on separation of concerns, and we're going to try to focus on unit testing. And so that's really the focus for today, because what the maintaining of code is what costs the most for businesses and people like myself that do work for companies. Maintaining is usually really what costs the most. So by unit testing, you ensure quality code, and you also ensure that you can find the bugs that are needed quickly. So I'm going to go through this fairly quick. If you need to pause the video and catch up, then you absolutely can. But really where you can go is you can go to Visual Studio, right? And click on this and you can download the community version. I am actually using Enterprise, but that's okay as well. Any of them is just fine and work just fine, but I'm going to assume that you hit pause, you downloaded that. The installation takes roughly 30 to 45 minutes. But alright, so I'm going to go ahead and open Visual Studio up. It's opening on the other screen, and here it is. So we're going to go ahead and we're going to start this project. We're going to hit create a new one. We're going to choose a classic desktop. We're going to choose a console application, and then we're going to call it Calc. Okay, so that's the name of our project. It's not the best name in the world. You can name it whatever you want. Personally, again, this is really so that you guys get a little bit familiar with unit testing and the ability to use separation of concern, so that you can use things across multiple projects, and the less work you have to do, the better. Alright, so first things first, we are going to go ahead and hit Manage NuGet, and we're going to hit Browse, and we're going to go ahead and choose Prism. There it is. I don't know why that didn't work. Alright, so here it is. We're going to hit Accept. Alright, so very first things first, we want to go ahead and add another project. We're going to just dive on into separation of concerns, so that we can use this across multiple projects if we need, or multiple reasons to use it. So really we just need a class library. It's a .NET framework, still under the same thing, and we're going to call this calc.biz, which stands for business rules, Alright, so let's get rid of this. We don't need that. Let's create a new folder, and we're going to call it Alright, so we're going to create another thing that's going to be an output. This is going to be another class library, and it's going to be calc. Okay, and this and an input. We will not dive too far into different types of inputs and different types of outputs, because, well, you can Google those. It didn't work out so well. Let's delete that. And when you delete it, actually what you can do, you can go ahead and hit open to folder. It'll bring this up, and you see it's there still, so you just delete it. Alright, so new project. We're going to choose class library, and we're going to choose calc. So now we have an output and input. Really, you know, you can put them in separate folders, but you know, we just put it in separate libraries because, you know, in case you want to import one from something else, you can do that. Or, you know, separation of concerns is all a very good thing. So basically we're going to go ahead and do this, and we're going to go ahead and interfaces here. So what we want to do, we really want to add a new item. Excuse me. And this is going to be an input. Okay. And we're going to have read. It's going to return a string and read. Okay. And we're going to have an interface here. Which is an output. Okay. And this is going to return a void, and it's going to be a write. Alright, so now we have those. Let's go ahead and add a class. Okay, he's going to go to public. I'm using ReSharper. You can actually type it out if you want, but I don't want to. So alright, so here's this, and we're going to just say return console. Alright, and that's about as much as that's going to need. So here's an output. This is going to be, let's put this in a folder. And you could actually make it something along the lines of console, or, you know, whatever you wanted to do. You know, we'll do that just because that's a little better. Okay, so now we're going to put alright, and he is going to be an output. Alright, so now we're just going to do console message. Alright, so there's that. Now let's go ahead and change this as well to console. And like I said, I'm using ReSharper, which makes a lot of this stuff a little bit easier. So now that's that. Alright, so now what we want to do, we want to let's go ahead and create a startup folder. This is going to be Unity, register Unity. Alright, so it has to be a static class. That part's important. And a static method. And we want it to return an iUnity container and register instance. Instances. Okay, and we wanted to say this iUnity container and container. Alright, so now we want to return container. Alright, so that's that. So first things first, let's go ahead and create a Unity container. Now we want to, first thing, we really want to create a program or something that will continuously loop and continuously allow us to create this calculator multiple times. So right here we want to add interfaces folder, and this is going to be an iRunner. You can name it whatever you want, but right, and then we're going to put also create a void method called run. Okay, and we're going to go ahead and create a calculator here that or a runner, and it's going to just implement iRunner. Alright, so really we just want to make sure this is going to work, and runner worked. Right, alright, so then we want to console.readline. So now what we want to do, we want to register this. So we want to say container.register instance. We want it to be an iRunner, which as you see it's not showing up. Now that's really important. The reason it's not showing up in IntelliSense is because we haven't included it. We actually want to include all of them. Okay? So now we can say iRunner is a runner. Okay. So that's strange. It didn't work. Alright, so register type. So that's the reason. We want to register a type, not an instance. I'm sorry, I apologize for that. But because we had the lines under there, we were able to see that it wasn't what we were wanting. So let's go ahead and now create a runner, bar runner equals unity container dot resolve, and we want to resolve a type of iRunner, which now it's not going to know about that because we haven't actually told it about it. So let's now we can say dot register instances. Which you can see there, ReSharper helped me out. So now we've registered it. So now it will know about that, and we can just say runner.run. So now we can run it, and we will soon see that it's got a build and so on and so forth here. But you will see runner working. So that tells us right there that we are actually in there, and that's really good. Alright, so here on out, we'll want to register stuff with Unity, right? Because that's how we know. That's how Unity knows which to use dependency injection, which will allow us to do a lot of really, really cool things. So, first things first. register our I input and our I output. So let's do that first. I try to keep all of these, you know, in alphabetical order because you really can have a lot of them, but you know, there's things that you can do to help this out, but you know, there's you know, libraries and so on and so forth that allow us to do you know, maybe not register all of them, but for this video we're going to definitely register all of them. Alright, so now we want to be able to have a calculator. So our calculator, we need an I calculator. Okay, and this is actually going to return a let's just make it return an integer. You can make it return a decimal or a double or a float or whatever you really want, but oh, what the hell, we'll make it a decimal. Alright, and we're going to so, being that we have a calculator that takes an X and a Y, we also are going to need to know what to calculate or how to calculate, which ideally should not be determined by the calculator. Because of separation and concerns, we want each object to have separate you know, separate things that it does. So single operation per thing. So let's not really worry about that right now. We'll get into that a little bit later, but I'm just going to go ahead and create a calculator. Alright, and he's going to implement the iCalculator. Alright, so that said, now we can simply return decimal. Oops, I'm sorry. Alright. So, we're assuming, which, you know, that this is only a, well, only addition. You know, which is okay for now. We don't really want to assume that all the time, but right now we can do that. Alright, so we need to probably write a unit test for this. So let's go ahead and you can right click here and choose unit test. You know, accept all the defaults. So what we want to do, I have a code snippet that allows us to get this, but I just say calculator. Alright, so I have a code snippet that does this as well, and this should add two numbers. Alright, so bar x equals 2, and So now we can go ahead and go to tools, or I'm sorry, test. I usually use this. However, because you may be using this, we want to look up Test Explorer, which should be in View. If you're like me and have no idea where it is, you can go to the top and say Test. So what I did was go to test and hit run, and then it came up. So we're going to go ahead and leave it pinned here. You see that those passed, which is good. So now we can go ahead and use our iRunner. Here's our runner, right? Let's go ahead and ask for an iCalculator. An iInput. Oh, well, it's not there, so what do we do? Alright, well, we got to add the references to those. We might as well add an output as well, because we're going to need that as well. So let's ask for an iInput. And ask for an iOutput. You just Alt-Enter will do that for you. If you have ReSharper, if not, then you might have to right-click or manually add it. I don't know exactly. So let's say while, and we're just always going to make it true. That means that it'll always be an infinite loop, which is what we want. Let's go ahead and add in a try, and if it does, it'll write that exception out, which is more than sufficient for what we need. Okay, so we want to get X and we want to get Y, so let's do an output. Write, and go ahead and say please type numbers to add. Okay. For X equals input dot read and var Y equals input dot read. Okay, so the problem here is these are strings, so we want to actually calculate what our value. So we're going to need to go ahead and probably do this. We want to say calculator.calculate. We're going to say decimal.parse. Alright. So that should return a decimal, which it does, and let's just say output.write. Alright, so it's telling me, whatever. You don't need to do that, it'll do all that by itself. Alright, so that's fine. So let's go ahead and try that out. And remember, this should just work, but so you see here it says please type the numbers to add. We're going to say 3 and 3. And now it says 6. So 5 and 10 is 15. So that looks like that is now working. Perfect. So now we want a way to figure out what type of calculator we want, because we don't always want a we just don't always want a addition. We want a subtraction, or possibly we want division or multiplication, or a sine or cosine, or whatever you guys decide that you want for a calculator. But right now let's get rid of our iCalculator. Let's just go ahead and get rid of this. Let's go ahead and go to Register Unity and get rid of it here. And we're going to use a new pattern that we haven't used so far. It's actually going to be called a factory pattern. And this is going to be, kind of a cool pattern. We want it to do a lot of really cool things for us, like choose what calculator we want. So right here we're going to go ahead and add a new interface, and it's going to be an iCalc. iCalculator factory, okay? And he is always going to return an iCalculator. Get calculator. And we're going to ask for a string that is calculator name. Very cool. So now when we put in a calculator name into this, it returns the correct calculator. Of course, we want to do, we want to make sure that, ensure it with our unit tests and so on and so forth. So let's go ahead and create this calculator factory. So this is going to be oh, look at that, I spelled factory wrong. Alright, so now let's go back to our Unity and register this. It could be a singleton if you know what that is. If not, then just do this. This again shouldn't matter. So, alright, we're going to do a few cool things here. We did CTOR, we want a dictionary, string, and an iCal. Alright, so first things first, we need to say if not, first things first, we need to say calculators equals new dictionary. Okay. So we also want to fill calculators. So we're going to use a little bit of reflection here that will allow us to look in the assembly and get all of the calculators, so later on we don't have to mess with this as well. So we're going to say assembly dot get executing assembly dot get types. So that's our executing, and we want to save our types. And we only want the types that are classes. And where we want type of iCalculator dot is assignable from X, right? So that will get all of the classes that are assignable from iCalc, or that are calculator. All right. So now we want to say for each type and types, we want to say calculators dot add, and the key is going to be type dot name, and we actually just want to say what we want to do is we want an iCalculator here, and we want activator. Well, so there is a little bit of a problem here, because if you need to create your own and have dependencies in there, you may have to pass those dependencies and ensure they all have those same dependencies. We're just not going to have any of them have any dependencies. If you decide you want to, then you can absolutely do it, but just for simplicity, we're not going to. And you see that it wants a type. That's not working. Alright, just a second, I'll look it up. Okay, so what it was that I wasn't casting it. So you have to cast it as an iCalculator, and now you'll see that it is a iCalculator. So we can also add the calculator. Alright, so very cool. Now we've actually know that we have all of the calculators that are in there, and we want to actually change this. Let's go ahead and change this name, because, well, it isn't just a calculator, it's actually an add So now you see that it's changed that, which is exactly what we want. So alright, let's assume that they are not going to add the calculator name in there. You know, the calculator. We just want to assume that they always say add, subtract, multiply, and I'm even going to abbreviate it with sub and mul and div. Alright, so what we're going to do is say var So we need to ensure that they actually, you know, make sure they have the first letter uppercase. You could do a little bit of logic if you wanted. I'm just not going to right now. I'm just not. You know, I'm not going to get into that. But you know, that's okay. So now we can say calculators. We want to say if so we've already checked it. So now we just want to say return calculators and calc name. Alright, so now let's create a couple unit tests here. And let's go ahead and create a factory. Alright. And we're going to create a method should return add factory or add calculator. So we can say we want a var calculator equals factory dot get calculator, and we're just going to say add. Alright, and we want to assert that r equal type of add calculator is the calculator. Get type. Alright, so now we have our type. We should be able to run this and see if it works. Oh, it failed, so let's look why. Name doesn't exist. Well, that's interesting. So let's step into it and find out why. So we step into it. Our calculators contain 1. It does have an add calculator as our key. Oh, look at that. So because we set it down here, it isn't set up here, so that's the reason. So what we can do, we can just do this. Alright, so now let's go back to it and try it again. And it isn't going to work because we didn't. Alright, now it should work. Alright, so it's green, so that's good. Now what we can do, we want to also ensure that we throw an exception. So should throw if name doesn't we want to say var calculator equals factory dot get calculator something. We know that we'll never have a something type of calculator, and we want to also make sure that we expect exception and a type of invalid operation exception. Alright, so let's go ahead and try to run this one. Alright, we can run them all. And they all pass. Alright, so now we want to get a few different types of calculators going here. Let's go ahead and get should return a sub calculator. Probably add a unit test for this. And of course you can add as many unit tests as needed for your different types of calculations. Some may do some things, some may do others, but this is just a basic calculator. So we're only going to run the add, subtract, and multiply and divide. So I'll hit pause and I'll go ahead and add multiply and divide real quick to both of the factory tests and each test for it, and then I'll come right back. Okay, so I have went ahead and added those. As you can see, I have a div test that actually does check for the divide by 0. If you want to look at it, it's very simple. Basically, we check if it's 0 and we say y cannot be equal to, and look at that, that's wrong. So 0, that's okay though. And then we just simply divide by it. We're not real getting into a whole lot of issues, but we did come into several tests. We also came up with the factory test that does check for mole, it does check for the div, and it does, that's correct there. And then, so those are all now working. As you can see on the right, we have green. It did take a few minutes. I apologize for that really long wait you guys had there. You know, so alright, so here we want to go ahead. We no longer need to inject our iCalculator because we have a factory that will do it. So what we want now is we want an iCalculator factory. And we want to go ahead and delete him. And go ahead and introduce our read-only field. So, now what we want to change a little bit of this here, right? We don't actually want all of this stuff. We do, however, we want an output that is going to write, please type add please choose. Right. So now we want to say var function equals input dot read. So then we also want to say output right, please type X. Right, please type Y. Alright, so now this should say var value. Oh, wait, hold on. We have to get our iCalculator. So we have to get our calculator for our calculator. Equals factory dot get calculator, and we want our function in there. So now we have our iCalculator, and we can say calculator dot calculate X and Y. And we can now say output dot write and value dot toString. Okay, so now let's try it. Right, we could actually unit test this, which would be a good thing to really unit test. We can mock our output and our input, our calculator factory, according to whatever. However, I don't really, I don't think we really need to. The reason is, we can just test it right now, but if it was production code, we would definitely want to. So we have our please choose add sub mul, so we're going to say add, and it says type Y, and we're going to say 5, and it shows 8, and then it says please choose add sub. So this will probably break. So you see that calculator name doesn't exist, and that's because we have a lowercase sub. We know that, but so we can say 5 and 2, and now it shows 3. Alright, and we can say mul, and we can say 5 and 3 is 15, and we can say div, and we can say 3 and 4 should be 0.75. So it looks like it's all working pretty good. We can actually get a lot deeper into it. But for now, I think that we've kind of shown how much Unity actually does. And in this entire project here, our console application, right here, we have, looks like 5 lines that register Unity, okay? And we also have 3 lines that do the work. And I mean, that's the whole point of it. So within, 10 lines, we could actually add another type of calculator, maybe a WPF application, or some sort of web-based application. That may take a few more than 10 lines, but the key is the mass majority of it, as you see here, is all unit tested. And it's all, it's actually all into multiple different things. Now, if we wanted to change this from a console app or console input to maybe a Windows Forms input, or some sort of, file or something, we could absolutely do that if we really wanted to. But again, the key of this was to show you that Unity and Prism and so on and so forth can do all of these awesome things. And really, by keeping our separation of concerns, we have less than 10 lines of codes that we added to this console application that now does a calculator. And we can say, we want to add 271 to 225, or I'm sorry, and we get our value of 496. So it does absolutely work. And that is all that I'm going to show you for today. I hope you all had a wonderful video. I hope that you learned a little bit. Any questions or comments or anything you'd like to see about this, please post in the comments. Thanks.